So I'm going to do a quick introduction and pass it on to Angelo. We are from E.C.I Networks. E.C.I Networks is a system integrator based out of Montreal, Canada, focusing on open networking since 2018. So we have a product called E.C.I View. E.C.I View, it's a network performance monitoring tool to address 5G ultra-low latency use cases. And recently, on a Mac deployment, there was a need for TWAMP support on top of SONiC. So we built a container on top of SONiC, and Angelo is going to go in details over the solution and how we built it, what's the challenge, and we appreciate your feedback, how you can help us move this forward.
Thank you, Hassan. I guess going back to network performance, the traditional problems with existing legacy type of environments, traditionally using SNMP, ICMP, Echo, NetFlow, CLI to describe the age of certain individuals, and syslog messaging is that's typically used for performance management. But what we've heard in terms of feedback from a specific customer was it's just too limiting and extremely expensive, especially when you need to potentially expand the scope and the scale. And for that matter, even the cycle time to collect statistics, there's really drawbacks with using the legacy methods. So what we did was we looked at all the different open networking solutions out there, and looked at something that gave us the ability to do active packet monitoring, leveraging open source tools, things like latency and jitter, path trace, throughput, and also the ability to provide an open dashboard, so the ability for customers to create their own dashboards using open source tools. And then if they are kind of in a brown state or a brownfield environment, they've got the existing tools they need to integrate with. So we also are working on providing plugins for that. As Hassan mentioned, really this came to life as a result of a large SP in Canada that was looking to monitor 7,000 devices near real time, trying to get an idea of their cell tower latency and in almost real time. And so what we decided was to look at a platform that would integrate the open distributed TWAMP and OWAMP solutions out there. So we came up with a platform that'll allow you to deploy a TWAMP on SONiC as a container. And then on top of it, most of the OEM products today support TWAMP and TWAMP Lite. So you can kind of manage both environments, SONiC and or new, and the legacy just by configuring TWAMP capability. And the idea behind TWAMP itself is to provide the ability to do two-way delay, round trip time, including latency and packet loss and jitter. So what is TWAMP? I'm not sure if you're familiar with it, but high level, it's a standard protocol that's out there, built on RFC 5357, leverages client-server architecture. The intent is really to send or be able to send packets to an end device and then have those packets reflected back. And there would be a control session set up to do that. So the client side does both the setup of the packet send as well as sending the packets, and then the far end, which is called the server, would turn around and reflect that based on the request from the client. So some of the components of E.C.I View, we've got virtual machine images that we can use for data center deployments. There's container formats that are available to deploy on any Docker management platform. As Hassan identified, container as an extension to SONiC is something we've just recently done. We still got a little more work to do there, but we're quite close, and this is one of the reasons we wanted to come and and talk to the folks here at OCP. It supports both IPv4 and IPv6. And then in kind of the baseline of the product, there's what we call the E.C.I view bus. And really it's about tests that are configurable, and then all the results that are obtained from the tests are passed on via Kafka messaging to upstream systems. And then we natively support an archiving methodology local in a Logstash repository that's easily interoperable with open source platforms. The visualization part of the solution really allows you to schedule and run on-demand tests, continuous monitoring to do both real-time and aggregated result and collect aggregated result metrics. The ability to remotely control existing TWAMP-enabled devices with source destination traffic generation as well as QoS. So that's the really interesting part of this is the ability to do QoS and provide results through your network. The ability we've embedded in there is the ability to leverage Grafana and OpenSearch as well for visualization. And then we've also have an integrated UI, user-friendly and adaptable as well to the different environments out there. So, the best part about SONiC is its ability to expand and extend. And leveraging containers to do that is what we've been able to accomplish. Client server in TWAMP as well as TWAMP Lite is something we're working on as we speak. And the ability to be able to send packets to a device that's going to reflect without a control session is something we're working on right now. So one of the things that's unknown at this moment, and being very transparent with kind of our evolution or development of the product itself, is scalability. We really don't know how this will scale. That's something that we're going to work on, especially with the customer. We're working closely with him. The best part about the solution is it's hierarchical. It's a distributed architecture, so you could have your central visualization server that manages individual hosts that will actually execute the tests to the individual devices at the far end. And our call to action here is, this is kind of new to us, the idea of a community process, building something, and then posting back and collaborating. So this is, we're looking for your help. We're looking to expand based on input from yourselves, as well as push back features and enhancements to the solution so everyone can start using it. And on that note, I thank you for your time. Any questions?
Yeah. So a couple of questions. So traditionally, TWAMP-like technologies are implemented on endpoints to measure two-way delay between endpoints, not necessarily between networking devices. So what you're proposing here is actually to instantiate TWAMP capability on a switch, right?
That's correct.
But what are you going to measure? Are you going to create full mesh of TWAMP sessions between all devices on the fabric?
It depends on the use case, right? So in the case of the one use case that we're dealing with the customer is that's exactly what we're doing. We're doing a mesh, and the idea again, because we're looking at latency concerns to cell towers. The intent is because of the distributed fashion, they have data centers feeding certain cell towers, and so the idea is to look for holes or gaps and latency in their networks to the towers, and then obviously react to that.
So they're not densely meshed, and if you look at something like data center topology at size, not necessarily Microsoft, but smaller, the overhead of running full mesh will completely kill the solution. So you really need to look into how to optimize who's talking to who. You cannot create full meshes. I mean, we tried, Facebook tried. If you do it indiscriminately, inevitably fails because of the scale.
Okay.
Second question, you need to do this in hardware. I mean, if you do it in software, your timestamping, you lose the fidelity. So what's your plan with regards to hardware upload in SONiC?
I don't have an answer for you right now. I mean, this is something that, again, will evolve and develop and learn as we go. Hassan, I don't know if you have any.
No, unfortunately, no.
Thank you.
Thank you.
Great. Any more questions?
I have a quick question. What is the accuracy of the measurement you are expecting to get between the latency? Like what level of accuracy you are trying to achieve?
We are expecting around microseconds.
Microseconds.
Microseconds, yes.
Okay, so but then in terms of your agent, how low do you need to plug into the switch ASIC pipeline to be reaching that level of accuracy?
Well, we.
Or you are purely user space or?
Well, I believe we make sure like those network elements are synced with NTP or PTP.
Okay.
And we did already some measurement. I believe, Angelo, we did some measurement. It's already in a microsecond level.
Okay, so
precision.
you feel like the current way of integration, you are getting the level of accuracy you need. Is that the right understanding?
Exactly, and we believe this is the way how we're going to address those 5G use cases.
Okay, cool, thanks.
You need timestamping in hardware. If you're on software, you're too late.
Exactly, yeah.
Thanks for the feedback.
Great. Yeah, thank you
Great.
so much.
Thank you,
I think
everyone.
Thank you.
That, yeah,